And so here we have our second set of problems from the Advanced Math qualifier. And if we look at it, use the rule add 9. So we're going to generate a sequence. So this set of problems is about number sequences. And so you could start with 0 and then plus 9. So you do 9 and then plus another 9, 18, plus another 9, 27, 36. But you need not start with 9. You could start with 2. 2 plus 9 is 11, plus 9 is 20, plus 9 is 29, plus 9 is 38, and so on. Well, what comes next in this sequence? So how did we get from 64 to 16? Well, you could say it was minus 48. So you just check and you say, am I minusing 48 again? No, I only minus 12 to get to there. So then you say, if I'm going down, is it division? And indeed it is. It's divided by 4. So then we have another one divided by 4. So then we divide by 4 again and get to 1. Divide by 4 again and get to a fourth. So now we have to divide a fourth. And so what does that mean? Well, if you have a fourth and you divide it into 4 parts, now how big is each piece? It's a 16th. So you see what's happened is we go from a fourth, we go to a 16th. So we have 4 times as many pieces. Our pieces are 4 times smaller. And then if we're going to go down again, we're going to divide each of those into 4 parts. Okay, so now we have very small pieces. So we have a 64th. So when we look at this sequence, it's one where the number of the hop goes up. So from 2000 to 2007, we say, well, how much is it? Well, that's plus 7. But then what happens in the next one, to 2017, that's plus 10. Okay, so it was plus 7, plus 10, and we look at the next one, to 2030, it was plus 13. So it seems like we're hopping forward, but each hop gets 3 bigger than the previous. So let's see if that's true. So from 2030 to 2046, that's a jump of 16, 3 bigger than the jump 13, the previous. So we expect the next jump to be plus 19. Okay, so plus 19, 2 ways to do that. You could say 56 plus 9, 65, or you could say plus 20, 66, minus 1, because it's 19, okay, 65. So 20, 65. And then our next jump, we anticipate being 3 more than that, plus 22, so that would be 80, then 5 plus 2, 87, so 20, 87. So the trick in a machine like this is to look at 2 adjacent ones. So I've deliberately not have them next to each other, but what's the difference if you put in a 4 or a 5? So if I put in a 4, I get 15, and if I put in a 5, I get 17. So by adding 1 to the input, my output went up 2. Let's see if that's true for from 5 to 6. So from 5 to 6, I have 5 goes to 17, and 6 goes to 19. So once again, we added 1, and it went up 2. Okay, so it looks like it's a times 2 machine, but then something else is going on. So we say it's times 2, and then what else? Okay, so let's look. Well, 4 times 2, and then something gives us 15. Well, 4 times 2 plus 7 is 15. How about with 5? So 5 times 2, how do we get to 17? 10 plus 7. So we found our rule. So it's a times 2 plus 7. So that's our answer. It's a times 2 plus 7 machine. So this is a difficult looking animal here, but when you see something as wild as this, you could try and fit it into a single sequence, but what it is instead, easier to see as if 2 intertwining. So I'm going to do the one in red and the other in blue. And then you can see they're fairly simple, but they're just alternate. So in red, we have 1,000 goes to 1,002, goes to 1,006, goes to 1,012, goes to what comes next. Okay, so we have a +2, a +4, a +6. So we suspect the next one will be +8. So the next thing for that one will be 1,012 + 8, 20. So that's going to go there. Now let's look at the blue one. So the blue is 2,000, 1998, 1994, 1988. So we have -2, -4, -6, and next we have -8. So from 1988, it will go down to 1980, and that'll go in this last one here, 1980. So separating in two separate ones makes it a lot easier.